In the course of developing the core sample application, we've now encountered 4 resources: users, sessions, account activations, and password resets. Only the first of these is backed by an active record model with a table in the database. The time has finally come to add a second such resource, user microposts, which are short messages associated with a particular user. We first saw microposts in larval form in lesson 2, and in this lesson we'll make a full-strength version by constructing the micropost data model, associating it with the user model using the hasMany and belong_to methods, and then making the forms and partials needed to manipulate and display the results. We'll also add the ability to include images in microposts, which will give us a chance to learn how to upload and store image files in the cloud. We saw a sketch of microposts in lesson 2, and in this lesson we'll make a full-strength version of the micropost resource, associating it with the user model using the hasMany and belongs_to methods, and then making the forms and partials needed to manipulate and display the results. In the next and final lesson, we'll complete our sample app by giving each user a feed of microposts based on the users they follow. We'll get started by making a data model for microposts. As with the micropost model in lesson 2, this data model will include validations and an association with the user model. But unlike that data model, the one we make in this lesson will be fully tested and will also have default ordering and automatic destruction if the parent user is destroyed. Let's make a topic branch for microposts. Let's take a look at a diagram of the micropost data model. The first field here is the ID, which comes for free in Rails. We saw this in the context of the user model as well. The next field is the content field. This is what will contain the actual content of the micropost, which will actually be limited to 140 characters. So technically we could use a string, which on most systems can hold 255 characters. But the entry field for this content, as we saw in lesson 2, is a text area, and so this is more naturally thought of as a text field in that context. This also gives us some flexibility. If we decide to relax the restriction of 140, it'll be easy to accommodate that choice. And finally, there's no performance difference between text and string in the context of a PostgreSQL database, which is what we're using in production. The next field is a user ID. In the context of database modeling, this is known as a foreign key. This is an integer that identifies the user this micropost belongs to. And then finally, we have these magic columns created at and updated at that we get automatically by running a Rails migration. Speaking of which, let's make that migration. We'll actually do it as part of generating a model. You may recall from lesson 6 that generating a model automatically generates a migration. So the model is micropost, remember singular for models. And then we can add the content, which is text, remember. And then we could do this. We could do user ID integer, just following the diagram here. But there's actually a way to tell Rails that we want this to be an association by doing this. We can omit the ID part and just say user : references. Let's take a look at the migration that made. You can see here t.text content and our timestamps here that come for free. That's created at and updated at. These guys here. But then we've got t.references user. You can see that it puts an index on it automatically. Remember in lesson 6, we put an index on the email attribute of the user model. In that context, our immediate motivation was to enforce email uniqueness at the database level. But as a side effect, we also got efficient lookup when we did find by email. And that's why this is here automatically. Anytime you have an association, it's going to be required to find by this user ID here. So Rails automatically puts in an index. There's actually a second thing I want to do here, though, related to indices. We're not just going to be finding microposts with a particular user ID. We also want to order them by the time they were created. So that means that we want to include created at in an index. And there's a way to include both of them in a single index. So I'm going to add index on microposts and then give it a hash of symbols corresponding to the attributes. Because we're going to be finding by both of these attributes, we can put them together to form what's called a multiple key index. Save that and run the migration. We'll get started by writing a couple of tests for the kind of behavior we expect from the micropost model. Let's take a look at that here. Let's open the user test too, just to remind ourselves what it looks like. Remember, with users, we started with this basic sanity check. This test should be valid. So let's do the same thing over here. Of course, it's a micropost here. That means we need a setup method. And then we'll just put in micropost here, at micropost. Start off with just that. And let's fire up our guard window here. And if we save this here, it should be green. Now let's add a test for the presence of the user ID, without which none of the data modeling will work. So test user ID should be present. And then to do this, we want to set the micropost user ID to nil, but of course it doesn't even have user ID right now, so let's change that. That suggests introducing a user. Just pull it out of the fixtures. Now we can do this kind of assignment directly, but this is not idiomatically correct, and we're going to refactor this in just a few minutes. But for now, this will be fine. So now that we've set that user ID, let's do this. Set it to nil. And then say it should not be valid. That should go red. Right, so let's add the validation. By the way, you might note here that there's a belongs to user line that we did not put in by hand. That was created automatically by Rails generate model because of the user references line we put in. We'll see the result of this in a couple minutes, but first let's put in the validation. So validates user ID presence true. Should go green. All right. Now we'd also like to validate the presence of the content. Certainly blank content is invalid. We don't want to put that in there yet though. Let's do the test first. The content should be present, so let's do, I'm going to make a mistake here actually, so let's do content here. Content equals, let's just make it blank. Save it. Remember, I haven't saved this window over here. In fact, we can do this here. Save it again. You think, oh, it should be red. That's right, because we just added a failing test. Now let's put in the validation. Validates content. Presence true. Now we think, oh, we should go green. But we didn't. And the reason is because now this test should be valid has failed right here. And that's because this micropost in the setup method doesn't have any content. The reason we added this sanity check test, just to make sure that the setup micropost is valid, was exactly to catch this sort of little mistake. So let's put in the content. All right, now we're green. And finally, we want these to be microposts. That is to say, we want them to be small. So let's put a length constraint of 140 characters, just following Twitter's convention. So let's say test content should be at most 140 characters. Now you might remember that we had to solve this same kind of problem before in the user model. We had a test like this. Here's the maximum length of the name, and we just use this string multiplication. So let's do the same thing here. Let's say A times 140, 141, so it's a maximum of 140. So that's red, and then we can put in the same sort of length validation here. Length of maximum of 140. All right, now that we've got these basic validations in place, let's take a look at the user micropost associations. Let's take a look at some diagrams of the relationship between the two. All right, this is the association between microposts and users. Because of this belongs to, we saw this here. Each micropost knows which user it belongs to. And the way that happens is by associating the user ID with the ID of the corresponding user. And then the code to pull that user out is micropost.user. So this is the associated user here. Going the other way, we can talk about how a user has many microposts. And here the ID of the user is used to find the associated microposts based on the value of user underscore ID. And the way we access this list is using the code user.microposts. These associations give rise to a bunch of useful methods. Let's take a look at some of them. We've just talked about micropost.user and user.microposts, but the associations also give us these, user.micropost.create and createBang. This lets us create a micropost through the association. And then we also have user.micropost.build and user.micropost.findBy. This build here is the analog of new in that it doesn't actually create the record in the database, rather it just creates it in memory. What's cool about these methods here is that they let us create new microposts, either in memory or in the database, with the user ID automatically filled in. In other words, we don't have to specify the user ID explicitly, rather the ID is inferred using the association. To get this to work, we need has many and belongs to in the models, and half of the work has already been done for us. As I mentioned before, because of user::references in the model generation, it's here. Because of this, Rails knew to put belongs to user here, so all we need is the corresponding has many microposts in the user model. I like to put the associations right at the top. Has many microposts. That ran some tests. Let's take a look at it. Still green. Just resave it just to see. And at this point, we're in a position to understand why this code here is not idiomatically correct. You can see this explicitly specifies the user, or rather the user ID, but now we know there's a better way to do that. We can do it through the association like this. We saw here user.micropost.build. So this is @user.micropost.build. And then we can get rid of this part here. Save it, should still be green. In the process, of course, we've actually tested that @user.micropost is working. So if we got rid of this here, this will still be green because this isn't part of the user model test, but if we rerun the micropost test, now it's red because @user.micropost isn't valid anymore. So let's get rid of this, uncomment that, go green again. Great, now let's rerun the whole test suite just to make sure we're green. In fact, I don't think we've run it yet. Great. Before moving on to building the web interface for microposts, there are a couple of refinements I'd like to add to the model. These are exactly the sort of details that we punted on before, but now it's important to include them. One of the defining features of a list of microposts is that they come out in a specific order. In particular, they come out most recent first. But by default, this @user.microposts does not guarantee any order. In fact, it might be the right order, but we shouldn't rely on that fact. So let's add a test for what we want this to be. Say order should be most recent first, and then let's plan to make a fixture micropost called most recent. So let's do this, assert equal and this requires adding some fixtures for the microposts. We'll add a few while we're at it. Note that I'm putting the created@ column in by hand here. This is what allows us to control the order. Ordinarily, you can't set the created@ column, but inside fixtures you can. So let's say that this first one, this orange, was created 10 minutes ago. And then one of my favorite status updates, this is the town manifesto. A little bit of anti-pi propaganda. And I created that actually 3 years ago or so. And this is one of my favorite cat videos. Of course, ordinarily I would just paste that URL in. Here we go. Let's say it was created 2 hours ago, and then this is the one we want, most recent. This is our status update. Our micropost here is we're writing a short test. Let's say that was created at now. So by virtue of setting these created at values explicitly, we've guaranteed that this will be the most recent. So we can save that. This might actually pass. Let's take a look. No, it fails, so that's good. It's really nice to be able to get to red. It's really hard to arrange this unless you actually manipulate this created at column. So which one came out first? Yeah, so you can see the sad cats came out first. That's kind of weird. Who knew? So this is great. We've got a red test. Now we're ready to define the standard order. The way we're going to do this is with what's called a scope. Scope is actually a fairly general concept, but the only thing we'll need is something called default scope. Let's put it right after the belongs to user. Now, the argument of the default scope is a procedure that tells Rails how to order it. So the way to do that is to use this strange-looking arrow syntax. Let me show you how that works. This is what's called a proc. spelled like that if you want to Google it. So let's give this proc a block that just prints out foo. You can see that returns a proc here. This is essentially an anonymous function. It's a function that doesn't have a name, but we can call it like this, .call. So the argument here is going to be order. Well, let's look at the default, the easiest way to do the order. Ordinarily, you could just give it a symbol like this, order created at. Let's go back here. You may think, well, this is the right order, right? We want the order in which they were created, but no, that's still red. And this is because order by created at actually returns the one that was created longest ago first, but we want the most recent one. So the default order here is created at ascending, but what we actually want is created at descending. This requires pushing down to a little raw SQL. It's created at descending. It's actually case insensitive, but the convention is to put SQL keywords in all caps. Let's save that and see if it works. Great. By the way, I mentioned this stuff about procs. This is pretty advanced stuff, so if this is confusing, don't worry about it. Just know that when you define a scope like this, you need to put inside this block, after the arrow, a method that specifies the behavior of the scope. In this case, ordering created at descending, which, as we've just seen with the passing test, returns most recent first. Now, I've just learned from an alert Rails tutorial reader that as of Rails 4, we can actually replace this raw SQL with pure Ruby using a key value pair. So we could do created at colon and then make this a symbol. So this has the same effect. It's still nice to see that we can use raw SQL, but I definitely prefer to use pure Ruby if possible. So let's save that and see if we're still green. There we go. So there will be a little switch back to the old version because this is a quick insert into the screencasts. But this is definitely the syntax I recommend using. The second refinement we're going to implement is to destroy microposts associated with any users that are destroyed. Remember that admins can destroy users, so it makes sense to destroy the associated microposts. Let's take a look at that here. In this case, the application code is really simple, so I'm going to implement it first and then write a test. So the way to do it is just to add this one little bit to has many microposts. We say dependent destroy. Save that. Should still be green. Now let's write a test. This is on the user model now. So we can say that the associated micropost should be destroyed. That requires associating a micropost with the user defined in setup. It's this here. And remember, this is just created in memory, so first we need to save it to the database. Then we can create an associated micropost and destroy the user and make sure that that changes the micropost count by 1. So let's do that. We can create this through the association. And I'd like to use create bang in this context just to raise an error in case anything goes wrong. And then we can use our assert difference assertion. Micropost.count by -1. And then at user.destroy. Save that and see if we're red. Oh no, we should be green, right? Yeah. So now we can test that by this. Go red and green. Great. We're not quite done with the micropost data model. We'll be adding a couple more things when we talk about uploading images later in this lesson, but for now this is a great start, and certainly enough to let us move on to building the web interface for creating, showing, and destroying microposts. We'll start by writing the code needed to show microposts. Rather than putting a particular user's microposts on a separate micropost index page, instead we'll follow Twitter's lead and put the micropost on the user's profile page. Let's take a look at a mock-up of that. Here's the profile page with the gravatar, name, and then a list of the microposts with pagination and a count of the number of microposts. So these are the elements we want to add in this section. Let's start with the code to render microposts. As with users, we're going to define a micropost partial. Remember how that works here. We've got app views, users, and then we have underscore user.html.erb. We're going to define the analog of this for microposts. That means we need a micropost directory here in the views, and the easiest way to get that is to generate the micropost controller. So let's do that here. Remember, controllers are plural. That didn't generate any views, but we can add a view here. Let's open that up. This will be similar to user. Let's take a look at that. Just do this. We'll have an li, but in this case we're going to give it an ID as well. This is useful especially because microposts are coming out in a specific order, and this also opens up the possibility of testing the microposts and maybe even manipulating them with JavaScript. This isn't strictly necessary, but it's a good idea. So we want to give it the ID of the micropost, so we can just use embedded Ruby like this. Micropost.id. We can't do just ID by itself. We couldn't do this because you actually can't start CSS IDs with an integer. So we put micropost dash to make it valid. And then let's link to the gravatar. You can look at the mock-up here. I'll link to the gravatar for the user. Now you might wonder where this micropost is going to come from. Here. Remember the way that this partial works over here with this user partial is that we called it using render at users. This from the user's index. Right, we have render at users. Because this partial is named user and this is a collection of things with class user, there's automatically a local variable called user. That means we're going to be able to do something like this, render at micropost. And then inside here, there will automatically be a micropost variable. And we can get the user associated with that micropost using micropost.user. So we can do link to gravatar for micropost.user. Let's make it size 50, a little smaller than the default. And then the link should go to the profile page, which is just user path of user, in this case, user path of micropost.user. But as usual, we can omit this part and just link right to the user. If we look at our mockup, you can see we want the content and then how long ago it was posted. And for simplicity, I also want to include the user's name with a link, because that will let us reuse this on the feed. Let's do that here. Let's put this inside a span. Let us style it. And the content will also go into span with class content. Remember, this is escaped out automatically, so anything dangerous in this content will be escaped out and rendered harmless. And then we want to put how long ago it was posted. Give it a timestamp class. And this is a really cool Rails helper. Posted time ago in words. Give it a timestamp, and that's micropost.created@. Posted time ago in words ago. Save that. Now let's write the code to display the micropost. It's going to go on the show page. Show page for users, so this is just the profile page. So after this aside here, I'm going to put a div. This is a bootstrap class. And now let's say if there are any microposts, put in a header, setter here with the count, and then display the microposts. Here we're using the association again, if at user.microposts. .any question mark. Put in an H3. And the count. By the way, this count is done in the database. Rails doesn't pull all the microposts out of the database and then see how long the resulting collection is. This is actually really efficient. It's done right in the database. This is also the reason that count and length are different for paginated objects. Remember, we saw in a previous lesson that length returned the length of the actual collection, but count returned all of them, just the total number in the database. So here, we're going to see that at user.micropost is going to be paginated. We can get this sort of count here by using at user.micropost.count. Now we need to render the microposts. Because they come out in a particular order, I'm going to use an ordered list with the class microposts. And here we can use this trick, render at microposts. This requires a collection called at microposts. We'll define that in a moment. But first I want to note that we also want to paginate them. Remember here, we want pagination here at the bottom, so that's will paginate. Look at the index. Before we just did will paginate by itself. What this does is looks for an instance variable corresponding to the class of the controller we're in. So in this case, this is the user's controller. So it's looking for a variable called @users, which is in fact defined in the user's controller. Right, that's here, @users equals user.paginate. But here, we're actually still in the user's controller, right? This is the user show page. So in this case, we need to tell will paginate explicitly which collection to paginate, in this case, at micropost. So then over here in the show page, we can do this. Instead of doing at user.micropost, we can do at user.micropost.paginate page of params of page. So it's just like this here, except now we're going through the association. Rails and will paginate are so designed that this will just work, which is really cool. So let's take a look at it. Save this, and go to the user show page. And there's the user profile page, but there aren't any microposts, of course, because we're not showing them if there aren't any, right here, and there aren't any. To fix this problem, as with users, we're going to create some sample microposts using our seeds script. It would actually take quite a while to generate microposts for all 100 users here. There's 99 plus the first one there. So we're just going to create microposts for the first 6, especially since we want enough microposts to trigger pagination. So what we're going to do is create 50 microposts just for the first 6 users. Let's pull those users out of the database. And I want them in the order that they were created here in the seeds file. So I'm going to say user.order created at. Remember, we saw with the micropost model that this returns the oldest ones first, so we had to reverse it in that case, but in this case, that's what we want. And then we can just take the first 6. So the take method takes the first 6 from that list. Now at this point, we could iterate through each of these users like this, and then create the micropost here. But that would create big runs of, in this case, 50 microposts. And as we'll see in the next lesson, when we make the feeds, we're going to want the different users to be interleaved. So it's actually more convenient to iterate first 50 times. And then inside here, for each user, create a micropost. I'm going to create bang, just to make sure any errors are caught immediately. Close this off. And now we have to give it some content. I'm going to define a local variable inside this block. We'd like this content to be something that doesn't distract us from the design, but that has some variation. We saw up here that we used the faker gem to create names, and it turns out faker also has the ability to create lorem ipsum text. And in this case, let's make it a sentence of length 5. Save that and reset our database. Actually, let's do it here. We have to shut down the server typically. First reset, and then we'll seed. All right, let's restart the web server and see what that did for us. All right, all the microposts appear to be there. We've got the link, we've got the lorem ipsum text, the gravatar's working. We even have pagination. So it looks like this partial that we defined is actually working. Of course, the styling is a little crazy, so let's add some CSS. There's quite a bit. In fact, the CSS I'm going to include here is all the CSS we need for this lesson. So I'm just going to paste it in. Here we go. Save that. You can just take a look at the structure if you want. You can see we're styling the LI here, the list item. There's the user and content classes, the timestamp class, and the gravatar class. Let's take a look. Aha, much better. Looks like everything is working here. We can even look at a second user here. Let's look at 5. This is user 5. Pagination, as we saw before, is working, so it's still working. The CSS, of course, didn't change that. Great. Now that this is working, let's add an integration test for the user profile page. We already have a test that the profile page basically renders. Let's recall that. User show page. Let's just put an exception in here. See if that breaks something. Great, we actually have 2 errors there, indicating that if anything goes horribly wrong on this page, we're already covered. But now that we've put some more structure on the user show page, let's write a specific integration test for things like the title, the presence of a gravatar, and the presence of pagination, as well as the presence of the content of each micropost. We can start like this. Let's call it the user's profile test. Let's open that up. And let's just go down the list of things we want. Well, we definitely want a user. And so let's just pull that out of the fixtures. And let's test the profile display. Oops, sometimes that end appears and sometimes it doesn't. Still haven't figured that out. All right, well first let's get that path, that user, and insert template user/show. Let's go here. I like saving it incrementally here. And let's get the title. So it's the title tag, and then we want the title to be the user's name combined with the base title. So that's and then like this. Oh, in fact, we need to get rid of this raise, don't we? We're still red there. Okay, what failed there? Oh, that's right. This goes first. It used to be the other way. But you may recall that we have a helper for this. It's in the application helper. It's a full title helper. So we can actually just add that here. We can include application helper. And then just do full title here. Something to be careful of if you do something like this is to make sure to add independent tests for the helper that you're using, because otherwise you could put a typo in here and it would still pass. Right, so we've now introduced an error into the title, but there's nothing here to indicate that. If we rerun the whole test suite, though, we'll see we are red. That's because we hard-coded the title into some of these other places. On the static pages controller test, we've hard-coded Ruby on Rails tutorial sample app. So if you wanted to use this full title helper everywhere, which I do recommend, then you would want to write some specific tests for the application helper, in particular the full title helper. Writing such a test is left as an exercise, so if you get the solutions manual, you'll be able to see the test that I recommend. But in any case, this is working fine now. Let's save this. Just make sure we're green. Good. Next, we can check for a top-level heading in H1 containing the name and the gravatar. So let's do that. So we can do H1 and then text name as at user.name. And then we can also make sure the gravatar is there like this. We can do H1, and then inside the H1 should be an image tag with class equal to gravatar. So you can see if we change this up. Now it fails. So this angle bracket here, this greater than sign, indicates that this image.gravatar should be inside the H1. This is about as detailed as I would ever make an HTML test. I'm pretty sure that I want an H1 on this page, but this is the sort of thing that if you find that you're over-specifying it, you should change the test to be less specific. So what else do we want? Now we're getting to the micropost part. Let's make sure the micropost count is on the page, this here. We want it to be the right count too, so let's do... Now all we care about is that this be somewhere on the page. So there's a really nice, powerful way to do that. This is a way not to specify the specific HTML tag being used. Instead, we can just say it appears somewhere in the body of the page. I say body there, it's actually just the full text of the page. This is assert match. We're going to put in the count. Count. And we want to convert it to a string. So it should appear somewhere. And there's this response object available inside of tests. And response.body, despite its name, is not in fact just the body of the page. It's in fact the entire HTML. Save that and run it. We're still green. That's good. And now we want to verify that pagination is being invoked. And remember, we did this before. So in the user's index test, you can see we tested for a div with class equal to pagination. So we can do that same thing here. In fact, let's just copy it. I actually cut it accidentally, but then I could just undo and then it still works. Same thing as copy. And save that, and now we're red. So why are we red? Because this was passing, right? The count worked fine. And the answer is because the number of microposts is currently not big enough in the test database to invoke pagination. Remember, we've got the fixtures file here, but there are only 4 of them. And pagination is invoked by default at 30. So we're going to do the same thing we did with the users. Remember, we added 30 users to invoke pagination. So we can do the same thing here. Let's do micropost n. And we want the content to be lorem ipsum text. Do faker. Actually, let's do this here. And we want the created at to be long enough ago that it will never be most recent. So let's just make it quite a few days ago. Save that and see how we did. It's not going to pass, see if you can figure out why. It's still failing, and the reason is because even though now there are enough microposts to invoke pagination, in fact the user still doesn't have any microposts. And that's because, as you may have noticed before when I created these, none of these microposts has a user ID. Now it is possible to add a user ID directly, like this, but then in users.yaml we would need to specify an ID as well, like this. And that's really annoying. Happily, Rails has anticipated this problem, and it's possible to create associations using fixtures. So the way to do that is like this. Instead of user ID, we just say user Michael. In this case, Rails will look for a user with key Michael and just make the association automatically. So let's give the same user to all of these microposts. Now it should work. Let's go over here and save it again. Great. Now that we know that pagination is being invoked, let's check to make sure that the content of each micropost appears on the page. We're going to use the same assert match trick here that we use in this line. So we want to paginate this. First page. Each do micropost, and we want to assert match micropost.content and then the response body. You can see that it's really nice that we were able to use the faker gem inside here, because if we hard-coded this, each micropost would have the same content and this test wouldn't be very good. But because in general these sentences will be different, it's a good test. Alright, this is a pretty sensitive test for the user profile page without being too specific about the HTML structure. So the next step is to actually be able to manipulate microposts through the web instead of relying purely on generated sample data. We'll get started with creating and destroying microposts by editing the routes file. To add some routes for this micropost resource. And we're going to add only create and destroy. Note that we haven't added routes for the new or edit pages, and that's because we're going to manipulate microposts through the user homepage and profile page rather than using separate micropost views. Let's get started on the interface by defining some access control in the micropost controller test. I should save this here. Both the create and destroy actions should be protected. In particular, they should require logged in users, so let's set that up. Let's just use the first of these fixtures. Remember, here they are. Just using this one here. And as with the analogous test for users, let's do that. Users controller test. So remember, we did this here. Let's look for assert no difference. Here it is. So we're just going to make the analog of these two. Although actually it's just the analog of this one here for the create action and for the destroy action. So let's try that. Assert no difference in the micropost count. And that's if we post to create. And we have to give it the right parameters here so that the route resolves. And we should probably redirect to the root URL here. This is the standard place we redirect when someone tries to do something they shouldn't. This is the same thing here, except I'm going to issue a delete request. And that needs an ID, which is just the micropost. Remember, Rails converts this to the corresponding ID. So let's save that and take a look at our tests. Right, they should both be red. And actually, the error here indicates a failure to generate the route. I'm a little surprised by that. Oh, and that's because if this post, it should be a delete request. Oh, it should be delete destroy. Right, there we go. Yeah, so now these are the errors I was expecting, namely that it can't find the destroy action or the create action. Good. So let's define those. Should be a different error. Right now it's missing the template, it says. But of course we really want to redirect, so we can just put a filter in here. Now we did this before, remember, in the user's controller. We have this before action logged in user. So we basically want the same line here, except instead of these 4, we just want create and destroy in this line here, the list of actions being protected. We save that though. Now it's going to complain that we don't have this before filter in the micropost controller. And that's true. It's defined down here. It's defined in the user's controller. And that was fine before, that we only needed it in the user's controller, but now we also need it here. And indeed, this filter is potentially generally useful, so let's move it from here to the controller that's the base class of all controllers, namely the application controller. If we put it in here, then because of inheritance, because of this line here, and this line here, it will automatically be available here in the micropost controller. So let's save this here, save, and we should be green. Oh, looks like there's one error. Oh, look at that. I still have this error here. I forgot to fix that typo. I told you it's really important to have independent tests of that helper. So let's do that. There we go. In this case, the error got caught because there's this hard coding, but this is why if you're going to eliminate this duplication by using the full title helper in all the tests, it's essential to write an independent test to catch this sort of thing. So it should be hard coded at least one place in the tests. So let's save this, close this up and rerun the test suite. Now 2 failures. Oh, and this is because there's actually an error in the test. In fact, logged in user redirects to the login URL, which is fine. That's the right behavior. There we go. Now we're ready to write the interface to create new microposts. Let's take a look at a mock-up. Our plan is to put this form on the home page. So at the upper left, we expect some information about the user, and then this text area with a button to create the micropost. Let's write the create action first. We can take a look at the user's controller, just to remind ourselves how we do this. So here are the steps. First, we need to create a new micropost in analogy with this line here. And now instead of doing micropost.new, we're going to do current user.micropost.build. Remember our table here. This is the way that we create a new user in memory. This is the analog of user.new over here. But now we go through the association, and of course the user in question is the current user that's logged into the session. As with users, instead of giving it a params hash, we're going to give it strong parameters, in this case called micropost params. And then we need to define it, just like we did over here. User params, just copy this here. Actually, we can copy the private part too. Here we go. And then it will be params.require micropost permit content. That's the only thing we're permitted to edit through the web, is the content. So let's go back up to the create action. Now we can say if at micropost.save, it's the same thing. Let's give it a flash message. Redirect to the home page, else we want to re-render the home page with some error messages. Now, as we'll see, we'll be able to reuse the error messages partial, so the error messages will happen automatically, so we just need to render the home page, which is at static pages, home. So this is our best guess at the back end. Now let's write the front end. It's going to be on the home page. And now we're going to actually change the home page depending on whether the user is logged in or not. So this stuff here will be for non-logged in users. That means we can do this. And in this section, we can put in the code for logged in users. So let's do this. Tab it over. If logged in, else. Now, I don't like having this much content in the two branches. We're going to have quite a bit here, and then there's all this stuff here. In general, I would define partials for these, but that's fairly straightforward and is left as an exercise. All right, let's look at the mockup again. There are basically two things we need to render. We need this user information here in the upper left, and then the form for creating new microposts. So let's put those in partials preemptively. Let's make a row and an aside. Again, these are bootstrap classes. And there are two sections in the aside. I'm going to put the user information in a section with class user info, and let's render a partial. We might potentially use this partial on multiple places in the application, including multiple controllers. So let's put it in the shared directory. And then the second section will be class micropost form. That's this here. Again, these class names are arbitrary, but if you look at the CSS that we pasted in earlier, it has styles for these classes. We'll put that in a micropost form partial. Let's define those partials now. App views shared. And let's make the other one while we're at it. Okay, if we look at the mockup, we've got a gravatar, name, a link to the profile, and the number of microposts. So let's do that. This is the gravatar for the current user. Let's make it size 50. And that's going to be a link to the user path of the current user, so we can just say current user. And then let's make this an H1. Top level heading, which is the name of the user. Oops, I need to put this inside an embedded Ruby. And then let's use spans for the profile link and the number of microposts. So again, I need to put it inside embedded Ruby. Now it would be tempting to put current user.micropost.count here, like this. This would match the mockup, right? 50 microposts. But what if there's only one micropost? Then you'll get one micropost. We saw the solution to this before. It's the pluralize method. We used it here in the error messages partial. This form contains pluralize the count and then the word to be pluralized. So we can apply the same idea here. Pluralize the count, and the word is micropost. That's the kind of thing, if you're feeling ambitious, you can write a test for. And let's look at the micropost form. This is a form for a micropost. Form variable f. And let's put in a div of class field. And this is now f.textArea. Corresponding to the content. And then we need a submit button. Say post. And this requires, this app micropost requires that there be a micropost instance variable on the page. So let's look at this. This is on the static pages controller. This is in the home page, so we need a micropost here. So the way we would normally do this if it were just by itself would be to do micropost.new, but remember we have an association, so we can say current user.microposts.build. This is just a new micropost. It doesn't need to be initialized with content because that's what we're going to do here. We're going to submit content. But we do only want to define this if the user is logged in. All right, let's see the status of this. Save these. Save. Save. Let's go to the home page. All right, we have an error. There's no user. Where is this? Let's see here. Is it in here? Oh, it shouldn't say current user.user. It should say current user.name. Save that. Try it again. Ah, there we go. This is a good start. Let's see what happens if we submit it. That's even the right behavior, but you'll notice that there were no error messages displayed. I'm also curious to see if this form control class does anything here. So this is something like one of the new pages, new sessions. We had class form control. Let's see what that does here. The micropost form, text area content, class form control. That gives it a rounded view. I actually prefer the other one though. So let's keep it the way it was. I also don't like the size. Remember how we rendered the errors before? If we're here on, say, the new user page. Where is it? Remember we had render shared error messages. So let's copy that. Let's go over to the error messages partial. So we want to change this so that it applies to different kinds of objects. So let's just see what happens if we put object here instead of @user. can do this, pluralize object.arist.count. Save that and go over here and give it a local variable. Render the error message as partial with object equal to the parent object of the form, so that's f.object. So this form variable here knows which kind of object it is. So if we save this, take a look again. Oh, we still have @user in there, don't we? Yeah, it's right here. Let's try that again, though. This should work. Yeah, now we've got an error here. The form contains one error, content can't be blank. There's one more refinement I want to add. It's nice to have a little placeholder text here in the box indicating what should go there. And there's a convenient way to do that using this helper here, the text area helper. We can just give it a key value pair placeholder and then the string that we want put in there. Check that out. Actually, let's just go here. Great, compose new micropost. This will actually work. I can click post here, but of course I get redirected back to the same page and it doesn't show me the micropost. We're going to fix that up in a moment, but we can look here. You can see on the profile, it actually did work right here. We'll fix that issue by putting a proto feed on this page. In the next lesson, it will be a real feed, but it will be nice to have a first cut so that when we do submit a new micropost, it appears right away. We'll do that in a second, but there's actually something wrong with the application. You might suspect it. We can run our test suite. In fact, you can see the tests have already run. 5 errors there. You can rerun them. This is exactly the kind of change, this thing I made in the error messages partial, that's really dangerous. And it's hard to track down all the different places that it affects. But what's great about the test suite is that it'll tell us all those places. And in particular, it'll tell us when we're done. So what's happening here is that all of the places where the error messages partial was used before are now breaking. So let's look at that. Let's look in here, the new page. This needs a different kind of object. This should be, well, it's the same thing. It should be f.object. But in this case, it's going to be a user object instead of a micropost object. I can save that. Now there's only one error. It's an improvement. Now we can see the edit page has the same problem. All right, that's green. Let's rerun the whole suite. Still one more spot. The last place here is the password resets edit template. So let's look at that. And indeed, this is a form for an @user. You do the same thing, object, f.object. And now the test suite should be green. Great. We're pretty deep into the development of this application at this point, and we've developed a really good test suite. So the kind of changes we're making are exactly the kind of changes you would make with a more mature application, where you say, oh, well, we've got this error messages partial we made for users, but now we want to use it for microposts. But it's really scary to make these sorts of changes without a test suite to catch all these little places where things might have gone wrong. All right, I just mentioned this issue that on the home page, it would be really nice to display a proto feed, just a first cut of this micropost feed that we'll develop in the next lesson, so that when you post a new micropost, it appears on this page right away. Let's look at a mock-up of where we're going with that. So this is the idea, that we have the same things we had on the previous mock-up, just this user information area and the micropost text area. And then here we've got a micropost feed with paginated feed items. Since it's users that have feeds, that suggests creating a feed method on the user model. Just going to put that down here. We'll just call it feed. And then for now, we'll just return all of the microposts for the current user. So that's micropost.where user ID equals the ID of the current user. This is the first time we've seen the where function. This is a really useful function for issuing SQL queries. And this question mark here escapes out anything that gets inserted. Making sure to always use this question mark when you want to insert information into this query automatically avoids a critical vulnerability called SQL injection, sometimes called SQL injection. In this case, the ID is just an integer, so it doesn't really matter. But it's a good idea to be completely consistent because then you'll never be vulnerable. By the way, you might notice that this is essentially equivalent to saying this. Remember, we have user.micropost, so this is really self.micropost. But inside this user model, we can omit self. The reason I wrote micropost.where is because this formulation here generalizes more nicely to the full feed in the next lesson. So let's do this here, save it. Then on the home page, we need to have a list of these feeds. We should paginate them too. So let's go to the home template here. Actually, no, we want the user's controller, don't we? There are too many tabs here. This is a sign that there are too many tabs. Here we are. Oh, and in fact, I was still wrong. We want the static pages controller. That's where the home page is, right? The home action. Okay, so now we want to define an instance variable that has the items in the feed so that we can then put them on the home page as mocked up here. So let's call that @feedItems. Should only happen if users logged in, so let's do this. We just defined feed, so current user.feed should work, and we want to paginate them. Oops. And let's make a feed partial on the home page. We can do that here. Save that and go here. And after the micropost form, it's actually outside of the aside, right? This stuff here is in the aside, so we want a div. And then let's make it an H3. Doesn't matter too much. Let's render the feed. Of course, we need to make a partial for feed now. Yeah, so an error there because the feed partial isn't defined. So let's go here. And the feed should render if there are any feed items. It's going to be an ordered list. Let's give it class microposts. Let's render the feed items. And let's paginate them too. Save that and see how we're doing. We're pretty red there. Let's see what happened. Something is definitely very wrong. With the syntax error though, that should be easy to fix. All right, I just didn't close this off. There we go. This feed is now working. There's something a little mysterious though. Let's take a look at this partial. So here we got render at feed items. How does Rails know how to render that thing? We've talked about this before, but this is a really good application of it. So what is the class of each of these feed items? Well, each feed item is a member of this collection here. Static pages controller. So what Rails is doing here is it's seeing that this is a collection of feed items. It's saying, well, I should call a partial on each of these items. And it knows because the class of each item is a micropost to look for a template called underscore micropost in the micropost views folder. So that's why this is just working. It's because we defined this micropost view or this micropost partial. So before we had an instance variable called @micropost when we were rendering these things on the show page, like here, right here. But this variable name is irrelevant. What matters is the class of each object in this collection. Let's run our test suite to make sure we're green. That's great. There's actually one subtlety left. If we go here to the home page and submit an invalid micropost, say one that's blank, we get this error. Let's see where this is coming from. This is in the static pages controller. No, it's actually in the micropost controller. You can see here the URL is /micropost. So this is the create action in the micropost controller. Right, so what's happening here is that this micropost is not valid, so @micropost.save is false. So it's falling through to this right here. And this branch of the create action does not define an @feedItems variable. So it's nil, and that's why we're getting this. We're getting nil.any ? But there is no such method on nil. So that means we need to do something like this. Now I'm just going to do an empty array here. You can save this and see the results. Oh, let's go back. That's weird. Did I not save that? Huh. Oh, it should go before the render. Here. Right. So what happens here is that the feed just disappears temporarily. Now that's not the best behavior. The problem is that if you were to do something obvious like this, say, oh, well, let's just paginate it. Why not just do that? That seemed to work. And the problem is that if you go down to the pagination links, they're on the microposts. You can see right down here at the bottom. They're on the microposts URL, so /micropost. If you click on this, it'll complain. So it's possible to hack around this, but at the level of this tutorial, it's just not worth the trouble. So what we're going to do is do the next best thing and just make this empty. Now that we can create microposts, let's learn how to destroy them. It's pretty straightforward given what we did in lesson 9 with users. Let's look at a mockup. All we're going to do is just add delete links. Of course, these delete links should only appear for the owner of the micropost, and we'll arrange that. Let's put this on the micropost partial right here. So after this time ago in words, let's put a link to delete. We're actually going to put it inside the same span. And we should only put the link if the current user is the user the micropost belongs to. So remember, we have a current user boolean, current user question mark, and then micropost.user. And this is if. And let's link to the word delete. Link to the micropost. This is the micropost path of micropost, but we can just write that as micropost. And we want method delete. And let's give it pop-up confirmation. We did this before with users. See, that fits actually just fine. So that link should be working. Let's take a look. Oh, I forgot the closing bit here. All right, so we've got this, got the confirmation, but of course it won't actually work yet because we need to destroy action here in the micropost controller. We had something similar when we destroyed users. Here we had a correct user, the filter there. In this case, the correct user is finding by params of ID. Now we're going to find by params of ID again, except it's going to be through the association. So we'll do something like this. Correct user, and we want to say that micropost equals current user dot microposts dot find by, or we saw in the table right here. Find by the ID, micropost ID, which is what is in params of ID. Remember, find by returns nil if this doesn't correspond to anything in the database, so we can just redirect to the root URL if the micropost is nil. Otherwise, we'll have an @micropost variable once we apply this filter. And this is only on destroy. And then inside the destroy action, we want to destroy that micropost. At micropost.destroy, and then that's going to give a flash. And now we have to decide where to redirect to. So if we look at the current design, we've got the delete link here, so you might think, oh, we can just redirect to the root URL. But remember, we also see microposts on the profile page. So it would be convenient to redirect back to the profile page if that's where we deleted from. So you might ask, is there a way to get the page that referred the delete request? So if you click here, is there a way to get the place this is being issued from? And the answer is yes. It's related to this thing we use in the sessions helper. Remember, with friendly forwarding, we remembered where people came from, request.url. It turns out this request object has something else that's really useful. It has the referring URL. So we can do redirect to the refer. And if that is nil, then we'll redirect to the root URL by default. By the way, I should mention that this part here is almost never going to happen in real life. Because even if we're on the home page and we issue a delete request, in this case, request.refer is the home page. So the reason this is here is mainly because in some tests, this thing here, request.refer, will be nil. So let's check it out and see if it's working. Here we go, micropost deleted. Go from here. All right. You can see it redirected here to the show page, which is the right behavior. Alright, adding delete links is potentially dangerous, so it's a good idea to write a test to make sure that users can only delete their own posts. And we've also added several elements to the interface here, so it would be a good idea to write an integration test to capture that behavior. Let's close things down, a bunch of tabs here. And now let's get started by editing the micropost fixtures. And let's add a few microposts for other users. This will make it easier to test the microposts. Let's go down to the end here. Actually, let's get rid of that white space. And let's add one for this user, for Archer. So that's this. Let's call it ants. Content is, oh, is that what you want? Because that's how you get ants. Need to be created at more than time.zone.now ago. So let's say it was created at 2 years ago. Oh, and we need to give it a user. And then let's put in a few more. And create a couple for a different user. We won't actually use these last two in this lesson, but we will in the next one. Now let's write a test to make sure that a user can't destroy the micropost of a different user. It's going to go in the micropost controller test. This is where we put the access control tests. So the strategy is to log in as Michael here at the top, and then try to destroy this micropost here, ants, which belongs to Archer and not to Michael. So we can use our login as helper. And then we need to assert no difference in the micropost count if we send a delete request to the destroy action with the ID of a micropost that doesn't belong to this user. So let's say micropost of ants. And the test is read there because I haven't saved this fixtures file yet. I meant to do that, but then forgot. Let's save this again. There we go. No harm done. And with that access control test done, we're now ready to make an integration test for the micropost interface. Let's go here and generate that. Let's call it micropost interface. All right, let's open that up. we're going to want to log in as a user, so let's do this. And let's test the interface. All right, we log in as the user, and then let's get the root path. Make sure pagination is being invoked. Remember, we checked pagination on the user's profile test, so that was for the show page. Now we're going to check it for the home page. Actually, we can save this, work incrementally. All right, and so let's check. Let's just go through the things. We go to the home page. We make sure that pagination is invoked. And then let's make an invalid submission, like this. This is the micropost path it's being submitted to. Actually, let's put in a comment here. We post with, say, empty content. Anything invalid is fine, so let's just do this. And then this should give us that error explanation div. So that's what we expect for invalid submission. For valid submission, let's define the content. So that asserts that this actually increases the micropost count by 1. And in fact, if we're going to do that, we should probably do this too, just for consistency. We can add this, assert no difference here. Okay, so after we submit it successfully, we check that it changes the micropost count. And now we want to make sure that the content of the micropost appears on the resulting page. So that involves following the redirect. That's this here. We might as well assert the redirect too. And then we want the resulting response body to match the content. Let's check that. That's good. And now let's check deletion. Let's make sure that there's a delete link first. And now let's issue a delete request to the micropost path of the first micropost on the page. The difference should be 1 in the micropost count. we issue a delete request to the micropost path of that micropost. Oh, that didn't pass. What happened? We want to delete the micropost, so it should be difference of -1. You can see up here the difference is 2, right? It was 40, expected actual 38. That's because it was +1 instead of -1 for a difference of 2. All right, so that's working. And now the last thing is, let's see if we go to a different user. So this is the profile. If you go to your own profile, you should see these delete links, but if you go to someone else's profile, they should disappear. So let's go to a different profile. Archer is our canonical second user. And now we want to assert that there are no delete links. So we can do this. The way to do that is text delete. Oh, this is in quotes. This is what we did up here. Count 0. And this should not be a comma. And that's it. That's green. So let's take a look at the whole test suite. All right, so our basic microposts are now working, and they're well tested too. As a final step here, I'm going to refactor this test and break this long test into pieces to follow the practice from the last couple of lessons. It won't actually do much here, but there are a couple of exercises where having a separate setup method will really help. All right, so let's change this to this. Actually, we can copy this here. Remember, we want it not to be test for the setup method. And then we'll inherit from this. Make sure that's still green. Okay. Actually, we can log in here. We can hoist this up. And let's start off by testing essentially each of these. They're separated by comments, but we'll just make each of these a separate test. So we'll start off with a test for paginating microposts. Renaming it shouldn't change anything. So let's just get rid of this here. And we've got the error explanation and then this here. So I could save that. Something's wrong here, right? So you can see here there's a little hint that there's an incorrect bit of syntax. I'm probably missing the do over here, yeah. And also here. And then we're testing for the delete links. And here's the first thing we actually have to add. Before, when we had everything in one big block, we automatically got dropped into the user's path of the user after creating the micropost. So let's do this here. All right, here we have to navigate separately to the profile page to get this green. Let's test that the user can delete their own micropost. And finally, let's test that there should not be delete links on another user's profile page. So that's this here. And there we go. So this is a little more convenient because each test is separate. And it also means that if we want to add other things, we now have a good foundation for reusing the setup method here, overriding it using super, and so on, as we saw in account activations and password resets. This is an updated section on image upload, showing how to add images to microposts. We'll start with a version that's good enough for development use, and then add a series of refinements to make it production ready. Adding image upload involves two main visible elements, a form field for uploading an image and the micropost images themselves. In previous versions of the Rails tutorial, we had to use third-party gems in order to get image upload working. But as of Rails 5.2, image upload, and indeed file upload generally, is natively supported by Rails through a feature called active storage. Getting started with active storage is incredibly easy. All we need to do is type Rails active storage install. Now what that does is automatically creates a migration that updates our application's data model for accepting file uploads. We can take a look at it here. It's in DB migrate. You're welcome to take a look at this, but this is a good example of a situation where we don't actually have to understand the details. This is a hallmark of technical sophistication. Realizing that active storage generates this automatically might be interesting, but in fact, generally speaking, we're just going to be using the active storage API, the application programming interface, and we'll never have to deal with these low-level details. So let's close it down since we don't have to understand it, and migrate the database as usual. The first part of the active storage API that we need is a method called hasOneAttached. We'll put it in the micropost model, and it'll go under belongs to user, hasOneAttached. Image. hasOneAttached image, and I'd like to line these up. I think it looks nice. By the way, as you might guess, there's also hasManyAttached. We'll adopt the model of only a single image per micropost, but it's nice to know that we have the flexibility to add more if we wanted to. So this prepares our model, and now in the micropost form view, we need to add a place to actually upload the image. We saw this in the mockup right here. So let's take a look. This is what our form looks like right now. And so what we want is an image upload button right here. So let's put that in. There we go, put this over here. And what we'll do is put it in a class. There's actually CSS for this that we already included. Class equals image. And then the kind of form field for uploading something like this, like an image or any sort of binary file, is what's called a file field. We go to symbol with the name of the attribute. So we conventionally pick this name image to match this image here, but they could actually be different. I'll mention something more about that in a moment. All right, let's take a look. And there it is, choose file. So when we submit this, it goes to the micropost controller. And the create action. So here in the create action, we need to attach the image to the micropost that we just built. So that looks like this. We need to attach to the image attribute that we created over here with has one attached. So .image .attach. So this attach comes from active storage. And we'll want to say params of micropost and then image. Right, so this image here, put this over here, this image here has to match this, but we can say foobar and foobar here. It's convenient to use the same word just for clarity, but it's important to realize that the word image is being used in multiple contexts here. All right, now we've got the form. Click on choose file, we select a file, make a post, attach the image. So now there's an attached image and we can display it in the micropost partial. Let's put it right under the content. We'll use an image tag and then micropost.image. Let's take a look at this. See if you can figure out what will happen here. Right, so there's an error. Why is there an error? It says to model delegated to attachment, but attachment is nil. And that's because by default, microposts don't necessarily have images. Now, if you think about it, even though we haven't written any tests for the image upload, and that's left as an exercise, we do have tests for microposts. So this is the kind of thing that would be really nice if our test suite caught. And indeed, it is currently red. So what we want to do is display this image only if it exists, only if there is in fact an attached image. And active storage creates a method automatically called attached ? For exactly this purpose. So we'll say image tag micropost.image if micropost.image.attached ? And now we're green. This is a good example of the use of a test suite. Even though we don't have specific tests for this functionality yet, our test suite still told us that our application was broken. All right, at this point, it looks like everything might be working. Let's try it out. So let's choose File, put in a small picture of me, and then we do have to put in something here. If we submit, you can see that there's going to be an error. We still need some content. So do this, put in some content, submit it, and there we go. Now this is perfectly functional, but there's actually a second way to do this. I mentioned before that we could have used something like foobar here and here, but because we used a name that matches the name of the attribute, namely image, there's an even more convenient way to do this. In fact, this micropost.build method already knows to add the image. So we can actually get rid of this line entirely and then just add image here to the permitted attributes. This is the kind of little refactoring that it's nice to do after writing a test. And as mentioned, there's an exercise on adding a test for this functionality. So I suggest using the first method, using an explicit call to the attach method, writing a test, and then refactoring to make sure it still works. Speaking of which, though, we should make sure that our test suite is still green. And it is. So we're ready to go on to the next step. As we saw in the last section, we've got image upload working already. You can see here. I'm always amazed when things like this actually work, so it's really exciting that we got it working so quickly. There's a lot more to do though, so in this section we'll start by adding some validations for the things being uploaded. In particular, we'll add a maximum size for the images, while also making sure that they're in an acceptable image format. This is actually not supported natively by Active Storage as of this recording, but as is so often the case, there's a gem for adding this missing functionality, in this case called Active Storage Validations. Let's add it to the gem file. And I actually have the tabbing here already set up for it, so that the spacing is lined up. Again, as usual, you should use the ones online when in doubt, but this is working now. Let's look at the micropost model. We'll say validates content, then validates image. We'll start with content type. We can validate the content type to be in a certain set of valid formats. So in colon, and then %w gives us an array here of strings. And these are what are called MIME types. The valid image MIME types are JPEG, GIF, or GIF, depending on how you pronounce it, and PNG. So let's put those in. By the way, JPEG is the only valid JPEG MIME type, even though oftentimes the images themselves are .jpg. And we need to add a message for if this validation fails. Must be a valid image format. And then let's have the size be less than, say, 5 megabytes. This is all right from the documentation, so this is the kind of thing where you can either look it up there or you can follow a tutorial like this. Less than 5.megabytes, and then have the message let's try it out. So let's look at choose file. And I have here a copy of the Ruby on Rails tutorial. So this is the wrong format. It's a PDF format. And it's also too big. You can see it's taking some time. It actually does have to upload it. Ah, there's an error here. Actually, is this caught by the tests? Probably not. We don't have tests for this. Okay, that's too bad. That's the way it goes sometimes when you're doing this sort of thing. Oh, okay. So unknown validator, content type validator, this is a sign that the system hasn't been adequately updated with the thing we just added. So when you add a gem like that, sometimes you have to restart the server. So that's probably what happened. All right, let's take a look again. Refresh it. Actually, let's just do this here. Okay, so do it again. Has to upload it. We're actually going to add a validation on the client side to prevent these uploads. But we should have 3 errors because the content is blank and then there are 2 things wrong with the image. And there we go. content can't be blank, image must be a valid image format, image should be less than 5 megabytes. So it's working. That's pretty cool. But as we saw, this actually involves uploading the file. So it's convenient to prevent that sort of upload on the client side as well in the browser. And the way to do that is with JavaScript. Now, previous versions of this tutorial used a library called jQuery, but in the latest version of the tutorial, we're just going to use vanilla JavaScript. And in fact, it's very similar to what we did with the drop-down menu. Remember that here. So that's menu.js. We're going to create another file called imageupload.js that will detect that a file is too big and prevent it from being uploaded. Now we still need the client-side code because someone could always use a command line utility like curl to upload a really big image, but this is really convenient. It makes it a lot harder to make an inadvertent mistake and accidentally upload a really big file. We'll put this file in the same custom JavaScript directory we used for menu.js. Let's call it imageupload.js. And let's just copy this here to start. Some of it will be the same. Now this first part is identical. We're going to add a listener on turbo load. Remember, with vanilla JavaScript, that would be DOM content loaded. That's covered in Learn Enough JavaScript to be dangerous. But here, because of turbo, we have to use turbo load. And in this case, the event type, which before was click, is actually just called change. And it happens on the document itself. So we're going to get rid of this here. Actually, let's just get rid of this. We don't need both of them. So we can get rid of this let account. We're going to add a listener on the document itself, listening for change. And then let's pull out the image. It's actually the same thing here. Let image upload, document.querySelector, and now the ID here is actually just micropost_image. And that's generated by Rails itself. Right here, ID equals micropost_image. So we're going to grab this input field and we're going to calculate the size of the file. So let's do this here. Now we're going to use a different way of assigning something in JavaScript. This is actually a constant. It doesn't really matter that much. It would work either way. But it's nice to say that this is a constant. It's the size in megabytes. Since this won't change, we're going to call it a constant. And so this is a little bit tricky. You just have to Google around a bunch to figure out something like this. But it turns out this image upload has a files attribute. And the 0th element of that, so the first thing here, is the file in question. And we can calculate its size in JavaScript using .size, the size method. But this is in bytes, and we want it in megabytes. Oops, I forgot the equal sign here. So let's divide by the binary version of 1,000, once to get kilobytes, second to get megabytes. So the binary version of 1,000 is 2 to the 10, which is 1024. And this will give us the size in megabytes. And then we want to say if the size in megabytes is greater than 5, raise an alert saying the maximum file size is 5 megabytes. Please choose a smaller file. And let's clear the file field as well, since we're not going to upload this file. And the way to do that is to set the value to the empty string. Again, it's not important to understand all these details at this point. This is not a JavaScript tutorial. But there's one more thing we have to do, which is to tell Rails about the JavaScript. It's an application.js. So import custom menu. Just going to add custom image upload. And with that, we've replicated the original jQuery from previous versions of the tutorial. In fact, I can do it right here. Let's refresh. Maximum file size is 5 megabytes. Please choose a smaller file. Close. And you can see that it cleared it here. It would also be nice to be able to catch on the client side an invalid image format. And indeed, we can do this with an option to file field called accept. So we'll go here. Oh, no, it's right here. Yeah, file field image. And then we can say accept. And then the same valid MIME types. So like this. Try one more time, choose file. Ah, look at that. It's grayed out. I can't even select it. What about this? This is a full resolution file. Oh, too big. Now, it's essential to emphasize that these client-side validations are only for convenience. They don't actually prevent anything from happening. So for example, it's possible to use a command line client, something like curl, to hit this page, log in, and then upload a file that's too big. It's also the sort of thing you could do with a Ruby script or a Python script or something like that. So we still need the server-side validations in order to prevent the uploading of invalid file formats and files that are too big. But this is still really convenient because it will catch most of the cases on the client side. So it's convenient for us as the developers, and it's also convenient for the user. The validations in the last section were a good start, but it's still possible to upload an image that's under the maximum size limit, but still too big for the site layout. So for example, let's do this here. If I upload this image, this is only 819 kilobytes. But you can see it's still too big for the site. So what we want to do in this section is resize the image and then display a version that's the right size for the layout. Now, it's possible to resize this using CSS, but that doesn't actually change the image size. So it still takes just as much time for the browser to download the image. If you've ever been on a website where seemingly small images are still taking forever to load, that's usually the problem. So we actually want the image to be smaller. The cool thing is that Rails has a native way of doing this. There's a variant method that's part of active storage that lets us create resized variants of particular images. We still need to install a couple of things to get this to work though, so let's take a look at what's involved. The actual resizing is done by a really powerful program called ImageMagick. Among other things, ImageMagick supplies a command line command called convert. So you can check to see if it's already on your system by doing which convert, which will return the path to the executable if it exists. But here it's just blank, which means that it's not on this system. Now this installation is very much system dependent, so you might have to Google around a bit. There are some suggestions in the text. On the Cloud IDE, it's easy. You can just do sudo apt-get and then install ImageMagick. And then there's one gem we need to install called image processing. This is the current version, but as always, you should use the version at gemfiles 7th edition.railstutorial.org. We bundle install. You should probably type in the exact version number shown in the book, but this will use the current version on my system. And now there's one bit of configuration in application.rb. Can actually get rid of these comments here. Let's just put in config.ActiveStorage variant processor. And we'll use the variant processor that Ruby uses to talk to ImageMagick, which is called MiniMagick. Give it a symbol with that name. Okay. Now the way to actually do this in our application is to modify the attachment in the micropost model. So instead of saying has one attached image, we can say image do attachable. Then we're going to say attachable.variant. And then we can use whatever name we want here. We'll call this a display image. So give it a symbol called display, and then we need to give it the resize. Resize to limit, and we'll say that it's at most 500 by 500 pixels. And then in the view, this is the partial for micropost. We'll use that display variant to make sure that it doesn't break the layout. So let's go to here. We can just hoist this up. So instead of just micropost.image, we're going to say micropost.image.variant. It's from here. So the variant, and it's the display variant. All right, let's see if that worked. One of the nice things about using a variant like this is that it creates the variant the first time you need to use it, and then it caches it so it's fast the next time. This bigger image is already in our database. So if I refresh, the Rails app should automatically resize it and then put the variant into the layout. But this is also the kind of thing that sometimes happens. These are broken images. This is a sign almost certainly that we need to restart the server. So let's try that. We did quite a bit of configuration there. And there we go. Perfect. Let's try one more time. This will resize it in real time. And there it is. The only thing left now is to get this working in production. We've made impressive progress in this section already. We have working image upload with validations and resizing, but unfortunately right now it only works in development. Currently, the images are being stored on the local disk, and by local here I mean local to the Cloud IDE. But if we deploy this to Heroku, because of the way Heroku works, images will be reset every time you deploy. So obviously that's not acceptable for a production application, which means we need to store these images somewhere else. There are lots of options for this. Probably the most popular and the one I'm most familiar with is Amazon's Simple Storage service, which is part of Amazon Web Services. And conveniently, if you're using the Cloud IDE, you already have an AWS account. If you don't have one yet, you should create one now at aws.amazon.com. Then you have to create a user using what's called the Identity and Access Management Interface, IAM. It's just here at aws.amazon.com/IAM. Your users, add a user like this. Enable programmatic access here. Let's try this here. Administrator access, tags. We don't need this. Let's create the user, see if this works. All right, now we have an access key ID. and a secret access key we can show. Now, I'm going to blur these out because these are pretty dangerous to expose. It would allow anyone access to this account to upload arbitrary things, to change permissions, and so on. But you should copy these, and we're going to configure Heroku with these keys. I'm going to copy this here. Close. All right, there we go. Click on this here. Now we need to create a bucket. Create a bucket, say Real Tutorial Screencasts, US East region is fine. Go to next, 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 create bucket. And I think that's it. So now we need to configure our application. The gem file, so now we need to add a gem for Amazon. The AWS SDK, that's Software Development Kit for S3, and then the current version is this. Again, use the one online. Require false, I'm not sure why, but that's what the documentation said. Now the configuration here is in storage.yaml. Like this here. So test is disk, local is disk. This is now, well, whatever we want to call it. We'll call it Amazon. And now we need to have a bunch of key value pairs for the configuration. So this is service, which is S3. And now the access key ID and the secret access key from your account. This is the kind of thing that's dangerous to hard code, and Heroku has a way of dealing with this that involves not having to hard code it. It uses a hash called env. We actually saw this kind of thing before with SendGrid. So what we're going to have to do is tell Heroku about these keys as well. So let's do this. So this is the Heroku environment. So let's do this here. Let's just copy this. And this is secret access key. Let's line it up here. And then region, we'll just say env AWS region. And then the bucket, just put in the bucket name. And there's one more piece of configuration locally here in the app, which is in production.rb. Here we have config.activeStorageService equals local. We need to change that to Amazon. Add a comment. And that might be it. Just double check our test suite. We're not really testing this sort of thing, but still good to see if it's green, and it is. All right, so now the last thing to do before deploying is to do the Heroku configuration. At this point, we have to put in the access key ID, the secret access key, the region, and the bucket. I can do the region here. You can see here it's US East 2, so let's just copy that. This is the kind of thing that was handled before automatically by the SendGrid add-on, but here we have to do it by hand. By the way, we can do the opposite, just if you want to double check things. And then the bucket name. Rails tutorial screencasts. And now I'm going to put in my secret keys, which, again, it's important not to share. The whole reason we're doing what we're doing is so we don't actually have to write these things down anywhere in our app. So even if someone had the source code for our application, they wouldn't have access to these keys. All right, I think that's it. You never know, though. These are really hard things to get right the first time. So what we're going to do is deploy from this branch rather than going to master, merging in the changes. We're going to deploy right from the user micropost branch. And this is a useful thing to know how to do anyway. If you've been making commits as you've gone along, then you can go ahead and just say something like this. Or add production configuration. Or if you haven't made any commits this whole chapter, you can say something like add user micropost. So let's say add image upload. And now I'm going to do git push Heroku. And then say user microposts :master to tell Heroku that I want to treat this branch as if it were the master branch for the purposes of deployment. See if it works. All right, there we go. I'm always amazed when things like this work, so let's see if it actually does work. All right, we have to reset the database and reseed it. Obviously a really dangerous thing to do in a real production app, but this is just for our demonstration purposes. See the database. All right, here goes nothing. Will our production kitten work? Let's check it out. I can't believe it worked. That is so awesome. I've done this so many times, and I never fail to be astonished that it actually worked. Look at that. A production application, resized. It's really hard to believe. Amazing. The reason this worked is not only because we got all the configuration right, but also because Heroku has ImageMagick installed already, which is really convenient. It means the resizing automatically works, as do all the other things. Full resolution, too big. Look at that. Beautiful. This is a huge accomplishment. Not only do we have images working with our microposts, but this is also foundation for any sort of website that needs to accept file uploads. And it's all possible without ever leaving Rails using active storage. So everything in our interface is working in production, and we're now ready to move on to the final step. There's only one big feature left in our sample application, which is the social layer that lets users follow each other, resulting in a feed of the microposts of the followed users. We'll learn how to model these kinds of user relationships and see their implications for the micropost feed in the next lesson.